Hello everyone, welcome back to Pseudocoder. This is Ravina and today we are going to solve problem number 1249. So this particular problem has been recently very famous with Facebook. So if you have been preparing for Facebook, I think this would be a good choice to solve. So let's start by reading the problem statement. It says that given a string S of open and closing parentheses and lowercase English characters, your task is to remove the minimum number of parentheses, either open or close, in any positions so that the resulting parenthesis string is valid and return any valid string. Formally, a parenthesis string is valid if and only if, so these are some rules. It is the empty string, contains only lowercase characters, or it can be written as A concatenated with B, where A and B are valid strings, or it can be written as A inside the parentheses, where A is a valid string. So let's move on to our notepad and try to understand this problem first. Here I have taken example 1 from Leetcode. So let's see. So what it's trying to tell us is that we have a big string with us, and here we have to remove minimum number of parentheses so that this becomes a valid expression. So what does that mean? So here, if you notice, there are, let's count the number of open and close brackets. So here we have one open bracket, another open bracket, and I think that's it. And let's count the closing brackets. So we have one here, another one here, and then the third one. If you see that the number of opening brackets are actually not equal to the number of closing brackets, right? And also at the same time, they are not in the correct order. So suppose there can be a scenario where you have two closing brackets and two opening brackets, but they are in this format. It is still not valid. So not only the number of opening and closing brackets matter, but also their positioning. So here, if you look at it, you can see that there is one opening bracket that can have any of these closing brackets, and then another opening bracket that can have one of these closing brackets. So let's see how can we make this a valid string. Since the opening brackets occur before the closing brackets, what we can try to do is we can try to remove one of these closing brackets and that one of these closing brackets, and that can make it a valid string, correct? So let's look at some possibilities here. So the first possibility would be, say, let me get rid of this. Okay, so the first possibility that we can do is we can try and remove this one. So let's see how it looks. So if we do that, we have LEE open bracket C. After C, we are going to remove that bracket. So directly O, then the closing parenthesis and this. So if you look at here, this one has a closing bracket and even this has a closing bracket. Okay, so this looks valid. And how much did we remove? How many parentheses did we remove? We removed one. So let's look at another possibility. So suppose we have this. Suppose if we try to remove this one, the second closing parenthesis this time. So we have something, oh, sorry, not this one. So after C, we have closing parenthesis. We remove the one after O, and then we have D, E, and then the closing bracket. So here also you can see that this is valid and this is valid. So this is also a valid string. How many did we remove? We removed just one. And then the last scenario here we have is that we remove the last one, the last closing bracket. So let's see. Okay, we have this. Now you see that you have a closing bracket for this opening and then again for this one. So this is also a valid, and how many did you remove? Removed one. So either of these strings are accepted solutions. And if we remove any of those three, Leetcode will accept. So I hope the problem statement is clear. Now let's see how can we solve this. Okay, so we are going to solve this by using two data structures. One is set and another one is stack. Now, if you don't know what a stack or a set is, I have a Python programming series and I have covered both of these topics in details that are required for competitive programming. So feel free to check that out. I will drop the link in the description below. Okay, so let's get started. I'm going to copy the example that we had. So oops, CODE. Okay, so this is the example that we have. So the first thing that we are going to do is we are going to create a set. So I have my set, and then the next thing I need is a stack. So let's see, I'm going to draw my stack. Okay, so now that we have both of these things, the first thing that we are going to do is we are going to have a counter at the start of the string. So let me get that. So a counter here. The essential here, the working here is basically going through the list, checking for if we find an opening bracket, we add to the stack. If we find a closing bracket, then we check if our stack is, if we have a opening bracket for that closing bracket in our stack. If we do find it, then we just pop things out of the stack. If we do not find a opening bracket for our closing bracket, then we add that closing bracket to the set that we want to remove. Okay, so also we have to make sure that we keep an idea of what indices we can remove. So I'm just going to number it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so right now I'm pointing to 0. Here I will check, is this a parenthesis, either an opening or a closing parenthesis? No, it's not. Okay, we are just going to skip. So we go to the next one. We see that it is not a parenthesis. Okay, we go to the next. E is again not a parenthesis. We go next. Here I find that I have an opening bracket. Now, since I have an opening bracket, I will add it to my stack. So it is added here. Okay, I move forward. I check, is this a parenthesis? No, T is not a parenthesis. We move forward. We find another opening bracket. We add it to the stack. Then we find C. It is not a parenthesis. Okay, move forward. Then we encounter a closing bracket. Now that we have a closing bracket, what we will check is there a opening bracket in our stack? Yes, there is a opening bracket in our stack. Okay, we are going to pop that. So we are popping it. So I'm going to remove it. Okay, moving forward. We check, is O a parenthesis? No, it is not. Okay. Then we move forward. We find a closing bracket now. Now we check, is there a opening bracket in our stack? Yes, there is a opening bracket in our stack. Okay, so we remove that. Okay, so we remove the opening bracket. Now we come across D. Is D a parenthesis? No. Then we go to E. Is E a parenthesis? No. Finally, we find a closing bracket. Now the closing parenthesis we check. Is there anything in the stack? No, there is nothing in the stack. Okay, that means that this closing bracket can be removed. So the set that we have is going to be basically indexes that we want to remove. So we store the index of the closing bracket. And here previously I wrote down the indices. So it's 12. So I write 12. 12 is the index that we want to remove. Now we reach the end of the string. Okay, so what do we do now? Now we check, we actually concatenate, or you can say we gather all the indices that are part of the set and also any that are part of the stack. And why is that? Because when you have, say in this scenario, you had all the opening brackets first, and say if you have more number of opening brackets than closing brackets, so something like say this, if that is the case, and if you go through the algorithm, whenever you have opening brackets, you add it to the stack. So suppose 1, 2, 3. Then you get a closing bracket and then you start popping things. So you pop 1 for this closing bracket and now you get another closing bracket. So you pop this. In this case, we did not add anything to our set, but that doesn't mean that we don't have anything to remove. We do have a opening bracket that we should remove in order for the string to be a valid parenthesis. And that is why in the end, once we have traversed the list, we will take in all the indices from the set and also the stack. And then we go through our string and we create another string that is going to be a result. So going back to the first example here, let me get rid of this. This is not done yet. So we have one index in our set. So we now construct a new string. We go through the existing string and until we get to index 12. And then we just basically create a new string. So until we get to 12, so till 0 to 11, we have, so we come up till here and then we skip the 12th one. So we skip it, we are end of the string. So this is your solution and this is what we are going to return. I hope this explanation was helpful. And why do we need to union the set and the stack at the end of the computation? Now let's move on to the IDE and see how can you code this out. All right, so here the first thing that we actually need is a set that is going to store the indexes to remove. So I'm going to create one. So indexes to remove. Let's make it a set. Next thing that we need is actually a stack. So let's create a stack. Then we go through our string. So let's do that. So for I, comma C in enumerate. So I'm enumerating through the string because I want both the index and the character. So let's see if C is not a parenthesis. So you can check it like this. Not a parenthesis, then you just continue. Remember that whenever we found any character, any alphabets, we were just skipping it. So this particular condition is going to do that. And then otherwise, we check if we have found a open bracket. If we see a open bracket, what do? We just append it to this stack. So append I. And here we are appending the index because it will make us easier to union it later when we want to get the list of indexes that we want to remove. Otherwise, if we have a closing bracket, so else is going to fall into the closing bracket check. If we check, so when we have a closing bracket, we will first check if the stack is not empty. If the stack is not empty, then we pop it. Otherwise, we add it to the set. Okay, so we will see if the stack is empty. In this case, we will be adding it to our set. So we add that particular index to our set. Else, if the stack is not empty, then you pop it from the stack. Okay. So now we have completed the iteration. The index has reached the end of the string. In the end, what did we do? We actually union the stack and the set. So indexes to remove is nothing but indexes to remove dot union, and then you just create a set out of the stack and you just union both of them. Now in the end, we have a result to store the result that we want, and then we iterate through our string again. So let's say for I, comma C in enumerate S. So we go through it again so that this time we can drop the indexes that we want to remove. Then we check if it is not in the indexes to remove set, then you just append it to the result. So you append the character C. Oops. Okay. Here at the end, you are going to skip all the indexes that you want to remove and it will be part of the list. But here the return statement, if you see the return type of this particular method is a string. So we have to make sure that we convert it to a string. So we return string dot join and then result. So let's see if it compiles. Okay, let's submit. Yeah, you can see that it has been accepted. Now let's talk about the space and time complexity of this particular algorithm. If you look at it, you can see that we are going through each and every character inside the string once. So here you can see it is going to be O of n. If you look at this particular for loop, it is again going through the whole string once. So the time complexity of this particular algorithm is actually O of n. If you don't know what time and space complexities are, I have a video on it where I explain everything. So feel free to check that out. I will leave the link in the description below. Now let's talk about the space complexity. The space complexity here is, say for example, in the stack you are saving everything. In worst case scenario, if you have only parentheses, you end up adding them to the stack, and for the ones that you want to remove, you end up adding it to the set. So the worst case scenario of space complexity here is also O of n, because at a worst case scenario, you will be at a point where you want to remove all the parentheses or you have everything in one or the other data structure. So the space complexity of this algorithm is also O of n. So I hope this explanation was helpful. If you like my videos, give it a thumbs up, comment below. This really helps my channel. If you are someone who is preparing for, a Python based competitive exam, so feel free to check out my programming course. It covers everything in there. And thank you so much for watching and I will see you next time. Bye.